Hi, welcome to my class. And today we're going to learn about unit circle. The topic is from trigonometry. And these are the three topics we're going to learn today in class: radians and degree conversion, then finding arc length, and finding reference angle. Now, before we proceed, I want to know if I will ask the students if they have done the homework or not, or how is their math class, what is going on currently, which topic they're doing in the math class, and do they have any difficulty in that particular topic. Of course, ask them how did their day go around. Just a little warm up so the students can relax before we start. And then I'm going to show them, we're going to reflect on what their previous knowledge, what they should know to learn this topic. So let's move on to the so here is this is the review sheet which I will be sharing with the students, so they don't need to take down at this point. They will just review it with me, and I will be able to also check how much do they remember from the previous. So let's see. This is a review sheet for unit circle. This is a trigonometric table showing you the exact values. It shows sine theta, cos theta, tan theta, and all the degrees and radians listed on top. We do expect you to know the sine theta and cos theta exact values. And rest of the angles, you can, once you know these two, it's easy to find other values. And then let's look at the second figure here. This shows you the quadrant, how the signs are changing in each quadrant. So this is, if you look at this here, unit circle, this is my first quadrant here. This is my second quadrant. I hope you remember this. This is the third quadrant, and this is the fourth quadrant. It goes with the A, S, T, C. So when in our days, we learned it as all silly turtles crawl. So which means in the first quadrant, all the angles, the sine theta, cos theta, tan theta are positive. In the second, only sine is positive. In the third, tan is positive. And in the fourth, as you see, only cos is positive. This is very important for this. I expect you to already know this. And then let's move on to the next figure. This shows you the unit circle. Okay, here is the unit circle. If you see, these are all the values. And this was also the homework which I gave students the previous day. They had to draw the unit circle. So at this point, they can actually check their homework, and if they have drawn it correctly, they have to label the terminal points, which are these 1, 0, 0, 1, -1 and 0. And then this is origin over here, and this is x-axis, y-axis. Then these coordinates you should be knowing, all these degrees, 30 degrees, 45, 60, 90 of a unit circle. And this is x and y, where you should know that x represents cos theta and y represents sine theta. Moving on to next page. Then these terminologies I expect you to know are initial arm, what is terminal arm, principal angle, reference angle. If you look at the first figure over here, you can see initial angle. So if I will just draw the unit circle. And this is my circle. And this is my x-axis. This is where the initial arm. I can take another color here just to show you. This is my terminal arm. This is initial arm. This is the terminal arm. This is the initial arm. And this is my principal angle. And as you see in this figure, this is reference angle. All these you should be knowing. And then moving on to the next figure. You should be knowing about the coterminal angle. They are the angle which end in the same terminal arm. Okay, as the initial triangle, if you see here, theta is 40 degrees, and this angle from here to here, that is minus 320 degrees. So these are coterminal angles. And now just to check your understanding, I would like you to please match the following. At this point, the student is going to answer this so we can see how much he knows. So match each term with its definition from the choices below. Angle in standard position, reference angle, exact value, sine law, cosine law, terminal arm, ambiguous case. So let's look at the first one. It says, just trying to fit this in. Yeah, so the first one says a formula that relates the length of the side of triangle to the sine values of its angle. So that is sine law. So the answer for this is A. Sorry, sine law, that's D. Then a value that is not an approximation and may involve a radical, which means they're asking about the exact value. So here the answer is C. Then the final position of the rotating arm of an angle in standard position. Final position of the rotating arm of an angle in standard position, that is your terminal arm, which is F. Then number D, the acute angle formed by the terminal arm and the x-axis. This is my reference angle, that's B. Then an angle whose vertex is at origin and whose arms are the x-axis and the terminal arm. This one is angle in standard position, which is A. And then let's look at F. I will just scroll down so we can see more of the screen. F, a formula that relates the length of the side of a triangle to the cosine value of one of its angle, which is cosine law. So this is E. And then a situation that is open to two or more interpretations. So that's an ambiguous case, that's G. And so these are the answers. We'll just follow up with the student. After this, we'll move on to today's actual lesson. This is the demo lesson over here. So let's start with the first topic, that is radians and degree conversion. So I'm going to explain here. We're going to draw a unit circle. So this is a unit circle here. Please remember this is 0, it's 360 degrees, 0 degrees, and the equivalent is 2 pi radian. And then over here we have 90 degrees in degrees angles. Then this is 180 degrees. And over here it's 270 degrees. The equivalent radians is written as pi by 2 here. And 180 is 5, if you already know this. And 270, can you let me know? It will be correct. 3 pi over 2. Now this side, this is a unit circle with radius 1. So this is x. And then if I draw my terminal arm here, then this length over here is y, and my radius r is here. So radius in unit circle is 1. So 1 unit circle. And then 2 pi radian, as we can see, 2 pi radian is nothing but 360 degrees. Then pi is 180 degrees. So 1 radian is actually 180 degrees divided by pi, which is approximately equal to 57.3 degrees. Okay, so that's why we use here, whenever we want to convert from radian to degree, we multiply by this factor, 180 divided by pi. And whenever we want to convert from radians to degree, the vice versa, from degree to radians, then we need to multiply it by pi divided by 180. You can see the arrows. This is from radians to degree, and this is from degree to radians. This is very important conversion, because when we go to the next topic, that is finding arc length, so please remember, unit circle, the standard form is it's always given in radians. That's why we should know the conversion, so that we can always convert the degree angle if it's given in degree back to the radians. Now let's look at the questions here. How do we do conversion? I'll just give you an example. I'm going to clear what's on screen here, and let's take an example. For example, I need to convert 144 degrees to radians. So what I'm going to do is, of course, multiply this by, from degree to radian, pi over 180. So it's going to be 144 multiplied by pi over 180 degrees. When you simplify this, it becomes 144 divided by 180 multiplied by pi. This can be further simplified and written as 4 upon 5 pi radians. Please define the unit. So this is how you do it. Then another example. For example, you want to convert from radian to degree. So you can take 7 pi or 5. We're going to convert this to degrees. We're going to multiply this by 180 over pi. So you'll take 7 pi divided by 5 multiplied by 180 over pi. Pi and pi will cancel here. So this will, when you simplify this, you will get an angle of 252 degrees. So these are the two examples. For showing this example, we're going to check students' understanding and move on to a question. This one is a chart which has degrees, showing degree, radians, and work. So I would give 5 minutes to the students here to work independent and complete this table. Also help them in between if they need any help. So they can do it by themselves. It's a pretty simple one. And then moving on to next. topic, area of circle and sectors. So this is how do we calculate the arc length. Let's learn this. Now, if you know from before, I expect you to know the area of the circle, which is pi r squared. Can you at this point tell me what is the circumference of the circle? Circumference, the outside boundary. The circumference of a circle is given by the formula 2 pi r. That's correct. So if we look at this, if we draw a sector here, this is the arc length. We're going to learn the formula for the arc length. This is A. If you take this as A, and if you take the rest of the circumference from here all the way back to here, we can label this as A2. Then we can label the inside angle, we'll use another color, as theta 1. And then this outside angle can be labeled as theta 2. So the ratio we know in a circle, in a unit circle, with the radius r, it's arc length divided by the circumference is equal to sector angle divided by angle of full rotation. Angle of full rotation. Angle of full rotation is nothing but 360 degrees. So if my arc length is given by A1, and then circumference, as we know, is 2 pi r equals to sector angle is theta, and then angle of full rotation is 360 degrees. So please remember, in unit circle, our standard is we use radians over here. And again, instead of 360, you can write it as radian. So 360 in radian form is 2 pi. So let's substitute that here. Then we get A divided by 2 pi r equals to theta divided by 2 pi. So A is equal to theta. 2 pi r will go to the other side. It will be multiplied here. 2 pi r divided by 2 pi. Now 2 pi and 2 pi can cancel out. So we're left with the formula. Arc length A is theta multiplied by the radius, where theta, please remember, is in radians. This is very important. Now we're going to solve few questions related to this. If you have any question, you can ask. This is the explanation part. Just going to clear the drawing here and move on to the question. Let's look at this question. It says a circle has a radius of 32 centimeter. Calculate the length of arc subtended by an angle of 86 degrees. Use a circle to support your answer, which means you're going to show your arc over here. So let's draw. They're saying our radius from here to here, the radius is 32 centimeters. And it is angle of 86, which means little less than 90 degrees, so somewhere here. Okay? This angle is given as theta, which is given as 86 degrees. Now again, 86 is given in degrees, so we need to convert this to radians, please, the first thing. And they want you to find the length of the arc. So length of the arc using the formula A equals to, as we learned, can you please tell me? Correct, that is r multiplied by theta. And we need to convert 86 degrees to radians. So this is multiplied by pi over 180. So this comes to approximately 0.475. So we're going to use that value here. A equals to R is 32 multiplied by 0.475. The value of pi we can use as 3.14. So multiplied by 3.14 multiplied by 32. So my arc length over here is equal to approximate 48.007 centimeters. That's the unit we're using here. Please remember there is marks for the unit, so always define your unit. So my arc length is approximate, and it's better to give in 2 decimal places, so we can again get this as 48.01 centimeters. That's my final answer. Now part B, I would ask the student to go ahead and solve by himself. I will help him if he needs, but over here the diameter is given in this question, which means they need to convert this first to radius and then find the angle in radians. We'll give 2-3 minutes for students to solve this and then show them the working, how it's done, for them to check the answer. I'm going to move to my next question. Let's look at question number 6. It says, given angle theta lies in standard position with its terminal arm in quadrant 2, determine the exact value of cosine and tangent if sine theta is equal to 4 by 7. But this is a very nice question. Do you know sine theta 4 by 7? What is a sine theta? Sine theta is nothing but your opposite over hypotenuse. So sine theta is opposite over hypotenuse, which means my opposite side is 4 and my hypotenuse is 7. So if we have a right angle triangle like this, so this side is 4, this is 7, and we need to find the side. Using Pythagoras theorem, you can find the side. Which will be your adjacent side. So adjacent side using Pythagoras theorem, it will be 7 square minus 4 square. Adjacent square this is, which should give us under root. This is 49 minus 16. So my adjacent value here is, this comes to 33, root of 33. So this is why we need this. So once we have all the sides of the right angle triangle, now of course we can find, they want us to find cos and tan. Then cos, I'm just going to use this space here. Cos theta, as we know, is adjacent over hypotenuse, which is root 33 over 7, and tan theta is given as sine theta over cos theta equals to sine theta is 4 over 7. The whole divided by cos theta is root 33 over 7. So this comes to 4 over root of 33. So now one thing we need to see over here, they're saying the quadrant. So quadrant is 2, which means in the second quadrant, if we take this as a unit circle, in the second quadrant, only sine is positive, which means cos is negative and tan is negative. So these are the two values. Again, for tan theta, I would like to tell you over here, please don't leave the the root in the denominator. So you can always remove it and you can write the answer as 4 root 33 over 33 negative. So this is the value of tan theta over here. I hope you know how to do this. If not, I can explain. If a student needs extra explanation of removing the radical from the denominator, at this point I will guide them. Let me clear and let's move on to our last section of today's lesson. Reference angle, how to find out. Now this is a table, this is a diagram which shows you if it's in the first quadrant, the reference angle is same as your angle, the acute angle. In the second quadrant, it is 180 degrees minus the angle. In the third quadrant, it is angle minus 180 degrees. And in the fourth quadrant, again, it is 360 degrees minus the angle. Keeping this in mind, we will look at the questions here. Show your quadrant and difference angle work to determine the exact value of the following. These are the type of questions you get in exam. So let's look at this. The first one, it says sine 7 pi over 6, which means if we break 7 pi divided by 6 can be written as pi plus pi over 6. And it is more than 180 degrees because pi here represents 180, which means this will be in my third quadrant. So this will be in the third quadrant. Q3, Q6, where sine is negative in third quadrant. So now sine seven pi over 6, we need to find the reference angle so in this case it's more than 180 degrees. It's in the third quadrant, so we're going to use the formula for reference angle. I'm going to use reference theta equal to 7 pi over 6 minus pi, as shown in the figure above. So when you solve this, you get pi over 6. So sine pi over 6, the value is nothing but sine 30. So sine 30 is half. Now since it's in the third quadrant, so answer is going to be negative half. This is how you solve these type of questions. Now let's look at part B. If you want to try and let the student try at this stage with little guidance. Example, cot can be written as, it's opposite of tan theta, so it can be written as cos theta over sine theta. And then once give 2-3 minutes for students to solve here, just to see how much he's understood, and then I will proceed and solve it for the student. In this case, the answer is coming as negative 1 over root 3. That's my final answer. This finishes my demo lesson. Now we're going to just reflect on what all we have learned today. So let's look at the lesson review. I'm just trying to open the lesson review. Yeah, this is the lesson review here. So we're gonna see going to ask the students what they have. For the first topic we did is degree and radians. So I want to know the similarity and difference regarding the unit circle. So they can list any two similarities and a difference, and I can just see if they have followed the concept. For example, two similarities could be for degree and radian, they're on the same unit circle, and they have the same trigonometric values of the sine theta, cos theta, and tan theta. And the difference is that the difference regarding degree and radian is that basically the in calculations we always prefer radians. So we have to convert the degrees back to radians, and basically the degree is, I'll just show you using the diagram. The degree, just a second, sorry. And this is my circle. Degree basically defines the area inside this degree, this area, and whereas the radian is nothing but the arc length, this part of the unit circle. That's the difference. Then we're gonna reflect on the terminologies which we learned today, like standard position, reference angle, coterminal angles. And then third one, student need to tell me what was the last thing that they did. One more thing extra other than these, which was arc length, the formula for the arc length. And then I'm going to show them, this ends the lesson review. And then I'm going to show them their homework. So this is the homework which I have prepared for them. It's a 20-minute homework. So I'm trying to open this. Just reduce. So if you look here, this is a 20-minute with all the questions here. Angle ratio. And I have also written the time they need to spend on each section in the homework. Question number 3. And also I have created answer key for teacher use, which I'm going to share along with my demo lesson. I'm going to close this here. And before end of the class, I usually give students an exit question. It's called an exit ticket. I really like the concept. So this is the exit ticket for this class. They can simply answer this and then leave the class. So exit ticket for today's class is: when must angles be measured in radians rather than degrees in trigonometry? Now student is going to answer. So basically while calculating trigonometric like arc length and formulas and everywhere, we use radians instead of degree in trigonometry. And once you see down, this is a teacher answer as well for the exit ticket. And now this is end of my lesson. Thank you very much.